Good day, senior high school STEM students. I am your pre-calculus teacher, Sir Carlo Trosio. In this video discussion, we will be learning about the systems of nonlinear equations. Specifically, we will be finding the solutions of these set of equations by substitution, elimination, and the graphing method. Let this video be your guide in answering the quizzes and activities in our learning management system. Let us start. In the previous lessons, we already learned about the conic sections and its graphs. This time, we are going to discuss systems of nonlinear equations. From the name itself, nonlinear equations, what comes into your mind? Nonlinear, that means it is not a straight line and can be composed of curved lines such as the conic sections, circle, ellipse, hyperbola, parabola, trigonometric functions, rational functions, and so many more equations, which is not a straight line or a linear line. So, as you can see in this graph here, there's an intersection, or there are intersections, which are point A, point B, and point C. We have two graphs, the circle, and this could be a trigonometric function or rational function, and they intersected in three solutions. So let us learn how do these things happen in this video. Let us define systems of nonlinear equations. It is a system of two or more equations in two or more variables containing at least one equation that is not linear. So it could be a set of equations in which it can have a linear, and sometimes it can have both nonlinear equations. Let us see. What do you think are these equations? X is equal to y plus 10, 4x is equal to 2y plus 2, 6, and so on. This first set. What is its degree? The degree is 1. Therefore, this is a linear equation, while the other one has a degree of 2, or the exponent of 2, and obviously it looks like an ellipse. It could be a parabola, an equation of parabola again, and the fourth one, it could be a circle or whatever. So that is a nonlinear equations. So again, anything that has a degree or an exponent that is 2 or more than 2, that is nonlinear equations. So again, a system of nonlinear equation is composed of at least one nonlinear equation. So the solution of a system when graph can be determined by its number of point of intersection. Let us see. Let us have this example. Example number 1. This is an equation of a linear equation, and the other one is a quadratic equation. The other one could be both nonlinear, and the other one is more on linear. So this example number 1, is this a system of nonlinear equation or not? Yes, it is, because it has at least one quadratic equation. The second one, both equations are nonlinear, therefore still it is a system of nonlinear equation because it says at least one. And the other one is of course not a nonlinear equation. Let us illustrate it even more so that you can understand. You have this a graph of parabola and a line. In this first example, it has no solution. Second, it has one solution, and the third one has two solutions, which means that the intersecting point or points are called the solution. There are two equations, two graphs, and there is an intersection point, or more than an intersection point. Another example, a circle and an linear equation, a circle and an ellipse. As you can see in this, it can create at least 4 solutions. And let us familiarize this application or website. The Dismas calculator and GeoGebra, you might be using this when you go to college, and especially in graphing. Okay, let us try to graph these four sets of equations and try to see the solutions. This is the first method, the graphing method, which is very easy if we have the Dismas calculator and the GeoGebra. This time we're going to use the Dismas. Let us try. So you may open the dismas.com/calculator in any web browser. So let us try to see the solutions of these set of equations in number 1, the x squared plus y squared equals 10, and the other one. So you're just going to type it in, like this is x squared plus y squared equals 10. That looks like a circle, and the other one, of course, it could look like a linear equation. Let us see. Yes, it does look like a linear equation. So they are intersecting in such point. Here you have -1 and 3. Okay, so the solution here is -1 comma 3. That's very simple, very straightforward. How about the second one? The second one looks like a linear and a parabola, x squared plus y squared equals 10. Let us see. Y equals -x plus 2, and the other one is x squared, let me type it in, plus y equals 2. Okay, this is a parabola and a linear equation. They are intersecting in what point? It could be in, let me see, 0 comma 2 is the first solution. Did I get it right? Okay, so the answer is 0 comma 2 and 1.414 comma 0. No, this one 1 comma 1. Okay, there are two solutions again, the 1 comma 1 and 0 comma 2. Very easy. How about the third one? Let us just try to finish all of these. You have x squared minus 6x, this is a long equation, plus y squared plus 2y equals 3. It looks like a, is it a 3? 15, sorry. It looks like a circle, or could be an ellipse. The second one is an x squared minus 6x minus 2y equals 3. You can try it using your own website. So how many intersections or the solutions are here? There are 3. 1, 2, and 3. The solutions are -1 comma 2, 3 comma -6, and 7 comma 2. And the last one, just to master this thing, you have x squared plus y squared minus 6x minus 2y equals 6. It is a circle, and the last one is x squared plus 4y squared minus 6x minus 8y equals 5. Okay, so it is a graph of a circle and an ellipse. As you can see, they are intersecting in how many points? 4 points. I don't know how to zoom it in. Okay, that's it. So they are intersecting in 2 points. Yeah, okay. So they intersect in -0.916 comma 1.816 and so on. Okay, so in this video, those are our goals, okay, to find the solutions. But with the graph distance calculator, it is easy. But how about we do it manually in graphing? And how about we are only given the equations through substitution and elimination method? Let us try to solve those. So in the context of architecture, why do we need to solve for the intersections? Well, as you may have observed in these pictures, there are intersections of curved lines and another curved lines or another straight line. And we need to somehow look at the points and the solution so that we can try to have a correct um, estimation of how to build this. Okay, so at least you know why we are trying to look at the solutions of the sets of equations, because in the real life scenario you are not only going to graph a circle, but you're going to graph so many equations. Okay, so these are the objectives that hopefully we can achieve at the end of the lesson. Illustrate systems of nonlinear equations. Determine the solutions of systems of nonlinear equations using techniques such as substitution, elimination, and graphing. So we already did the graphing, but that is only using software. But how about manually? And I know you already know how to do it, the graphing in conic sections. The substitution and elimination are going to be a long process, so stay uh, stay watching the video. And at the end, we're going to solve situational problems involving systems of nonlinear equations. Solving systems of nonlinear equations by substitutions. These are the steps. First step, choose one equation from the system that will be used to substitute in the other equation. So again, there are two sets of equations. Let me go back. Let us have example number 1, x squared plus y squared equals 10. And the other one is x minus 3y is equal to negative 10. So the first step is you're going to choose which one should be substituted into the another equation. This is like a composition on function composition. An equation is substituted inside an equation. So for you to do that, you need to follow the second step first. The second step is using the chosen equation, solve one variable in terms of the other variable. In this case, we have x minus 3. Suppose we are going to use x minus 3y is equal to negative 10 as the substitute, and the second one and the first one is the primary or the original function. So how to substitute? So we're going to solve for one variable in the substituted value. You have x minus 3y is equal to negative 10. So we are going to solve for the value of y. So to do that, we are going to transpose x to the other side, and negative 3y, it could be divided by negative 3, and on the other side also, so that you can have the value of y. Later on, we're going to have that those examples. Okay, going to find that out later on. Okay, so let us have the third step. Substitute the expression derived in step 2 into the other equation. So again, step 1, choose. So we choose this one, okay, as the substitute. We solve for y first by transposing x to the other side, and that is now negative x, and the negative 3 divided by negative 3. Later on, we're going to have examples. Okay, where is the negative 3? Okay, and the x is now negative x. So this is now the value of, cancel out this, y. So y is equal to negative 10 minus x over negative 3 this time. So you're going to substitute now the entire equation of y, which is now negative 10 minus x over 3, into this y here, this primary equation. That's the first step. And with that, there are x here and also x here. So the variables now are all x, all x's. So you can find the value of x, which is our step 4. Solve for the equation in one variable in step 3. So once we can create this, we can solve for this, we can solve for the value of x, which is -1, if you're going to compute that later on. And if you have the value of x, what about the value of y? How to solve this? Very simple. That is step number 5. Substitute the value of variable derived, which is x, -1, derived in step 4 to one of the equations to solve for the other variable. So you can substitute -1 to either of these equations. Example, -1 substitute to x, that is now -1 squared, that is still 1, plus y squared is equal to 10. So 1 substitute to the other side, that is -1. 10 minus 1, that is 9. Y squared is equal to 9. That is y is equal to 3. That is how you do it. Okay, so this is just a very simple example. So we are going to have the example later on. And to see if they are really balanced, okay, they are really balanced, we're going to check the answer by substituting the values of the unknowns in the equation. Okay, let us have our example number 1. Okay. In the example number 1, you're going to find the solution set of the following: x squared plus y squared is equal to 10 and y minus x is equal to 2. Let us solve this using paper. Okay, so let us try to solve the first example of substitution method. So as you can see, you have two equations. One is nonlinear, one is linear, qualified for a system of nonlinear equation because we have one. So let us try to solve. First step is you're going to assign which of these is the substitute, the first one or the second one. So the technique is to just choose the shorter one, which is y minus x is equal to 2. This will be our sub, and the other one could be, we call this one as the primary. Okay, let's use this term. So first step is to solve for the sub, one variable for sub. So one variable for sub, that is, let us solve it here. The sub now becomes, let us solve for the value of y. So that is y minus x is equal to 2. We transpose negative x to the other side. That is now y is equal to x plus 2. So we now have the value of y for our sub. So the next thing we need to do is to substitute y to the primary. So the y, so the equation now is x squared plus y squared equals 10, and the y, which is x plus 2, will be substituted here. It is now x squared plus x plus 2, do not forget it has squared, equals 10. So you can see it can become a trinomial. So you have x squared plus, how to make it trinomial, x times x, x squared, 2 plus 2, 4x, 2 times 2, 4, that is equal to 10. Okay, so actually we can transpose 10 to the other side. Okay, so let us first combine like terms. That is now 2x squared plus 4x, and 4 minus 10, that is negative 6, equals 0. Okay, so for us to solve for the x, because our main goal here is to find the value of x and y, which are our solutions. These are our solutions. So we are looking for the value of x and y. So our first step is to find the value of x. So how to do that? So as you can see, the x squared has numerical coefficients, so we should divide it by 2 on both sides so that we can, like, this is already 0, okay? So we can, like, eliminate this. So when we eliminate, it is now 2 divided by 2, that is x squared, cancel. 4x divided by 2, that is 2x. Negative 6 divided by 2, that is negative 3, equals still 0. Okay, as you can see, we can factor this out. We can factor x squared plus 2x minus 3. What are the factors of negative 3 such that its sum is 2? It could be 3 comma negative 1. Did I get it right? Yes. 3 times negative 1, negative 3. 3 plus negative 1 is 2. Okay, so that is x plus 3 and x minus 1. So as you can see, we have 2 x's. So to find the x, just add 0. X plus 3 equals 0. X minus 1 equals 0. So you transpose here, transpose also the other one. That is now x equal to negative 1 and x is equal to, that is negative 3 and x is equal to positive. We now have the value of x's. There are two values of x, negative 3 and the other one is positive. We are going to find the value of y. How to find the value of y? So in finding the value of y, we continue. Okay, we are going to find y. So how to continue this? You're just going to substitute the value of x in either of the original equation. So in this case, we are going to choose the shorter one. But even if you choose the first one, still it would have the same answer. Okay, take note. So yeah, we are going to choose y minus x is equal to 2. Y is equal to x plus 2. It's still the same. Y minus x equal to, it is now y equals x plus 2. Still it would be the same. So that is y is equal to, value of x is negative 3 comma negative 3 plus 2. So that is y is equal to negative 1. Okay, so we have a pair, negative 3 paired to negative 1. How about the other one? X is equal to 1. How about we choose this or this, and let us just use this to make it faster. But again, it still has the same, okay, the same value. That is y is equal to x plus 2. X is 1 plus 2, so y is equal to 3. You have x and y, x and y, x and y. There are two solutions. Okay, so to illustrate to you that even if you're going to choose the other equation in finding the value of y, let us solve this here. Okay, just very short. We have x squared plus y squared is equal to 10. We use this, not this. Let's see if it would still have the value of negative 1. Suppose we substitute negative 3. Not in this equation, not in this equation, but in this equation. So let us have, the x is negative 3 plus y squared is equal to 10. So negative 3 squared. Negative 3 squared, that is 9, plus y squared is equal to 10. Transpose 9, that is now y squared is equal to 10 minus 9. So y squared is equal to 1. And y squared, it could be positive or negative 1. Still the same, negative 1, negative 1. And the positive here could not be correct if you're going to check it later on. So in this case, we are going to have the checking. Let us check if this set negative 3 comma 1 negative 1 is really the solution, and the other one is 1 comma 3. So in checking again, you may choose either of the equations. So now that we have the value of x and y, which are negative 3 comma negative 1 and 1 comma 3, we check them. So let us check. Let us use the shorter one. Y minus x is equal to 2. Our y in here is negative 1. Our x is negative 3 equals 2. Negative times negative, that is positive. Negative 1 equals 2. Negative 1 plus 3, that is positive 2 and 2. As you can see, they are now balanced. So that is check. This is a solution. Negative 3 comma negative 1 is a solution. The other one, 1 comma 3, you have, let me use this color. Y minus x is equal to 2. Y is 3 minus 1 equals 2. 3 minus 1, 2 equals 2 still. Negative 1 is 1 comma 3 is a solution. That's it. Very simple, nice and simple. Let us proceed to the second example. Let us continue with the second example. As you can see, you have two nonlinear equations. What have you observed? There is a similar variable, y minus 1 squared and y minus 1 squared. And we know that the value of y minus 1 squared is 4 times the quantity of x plus 6. Therefore, this equation here can be substituted directly by 4 times x plus 6. So with that, we can say that this equation is the sub and the other one is the primary. So there's no problem for us in solving for the value of y in here. So that's it. So we use the primary, which is x plus 2 squared, plus the y minus 1 squared happens to have the value of 4x plus 6. So y minus 1 squared is now 4x plus 6. Did you get it right? Again, you have y minus 1 squared and y minus 1 squared here. Therefore, the value of y minus 1 squared is 4 times x plus 6 is substituted in y minus 1 squared. So this y minus 1 squared is replaced by 4 squared times x plus 6. X plus squared, x plus 2 squared, y minus 1 squared becomes 4 times x plus 6 equals 16. Next step, simplify. Okay, make this a trinomial. X times x, x squared, 2 plus 2, 4x, 2 times 2, 4, plus 4 times x, that is 4x, 4 times 6, that is 24, equals 16. We combine like terms. You have 4x and 4x. That is now, let me copy the x word. 8x. 4 plus 24, that is 28, equals 16. And if we are going to transpose 16 to the other side, that becomes x squared plus 8x. 28 minus 16, that is 12, equals 0. That is 16. Okay. What are the factors of 12 such that it becomes 8? That would be 6 times 2. 6 times 2 is equal to 12. How about becomes 8? 6 plus 2, that is 8. So the factors are x plus 2 and x plus 6. And we know that we need to find the x, so we have to add 0 on the other side. X plus 6 is equal to 0. We transpose it directly. That becomes x equals negative 2 and x is equal to negative 6. So we have the values of x's. X minus 2. We write it here first so that we can have a guide. If x comma y, our x now is, let me box it in. Okay. Our x is, you have negative 2, sorry, that is negative 2 comma, okay. The other one is negative 6 comma y. We don't know, we do not know what is the value of these. So with that, we're going to solve for the value of y. Let's continue here. So in solving for the value of y, we use, let us use this second equation. Okay, we have y minus 1 squared equals 4 times x plus 6. Okay, let us use this. Let us substitute negative 2. So that is now y minus 1 squared equals 4 times negative 2. X becomes negative 2 plus 6. So that is 4 times negative 2 plus 6, that is 4. 4 times 4, that is 16. So you have y minus 1 squared. Okay, I hope you can follow. And as you can see, squared 16 is a perfect square, so you can square it off. Cancel, because y minus 1 equals 4. Transpose, that is now y equals 4 plus 1. Okay, 4 plus 1, that must be y equals, okay, as you can see here, you have, hold on, square root of 16, that is positive negative 4. So you can have positive 4, which is 4 plus 1, that is 5. And you can, this is now the value of y, if, because that is the square root of 16, that should be positive negative. So we have done with the positive. How about if y is negative 4 plus 1? So y is equal to, well, it became 1 because substitute, we simply transpose as negative 4 plus 1, that is going to be 3. That's it. So you have y is equal to 5 and 3. Therefore, the pair of negative 2 are 5 and 3. There are 2 pairs. So we must say we have negative 2 comma blank and blank. So we have 3. First, second, third. Negative 2 is paired with 5, and negative 2 is also paired with 3. So we have first solution, second solution, and third solution, but we are going to prove that one later on. So let us first solve for the negative 6. Let us not forget negative 6. So how to do that? We have to substitute it into this equation. We can choose either. You can choose this one too. Still has the same answer. So you have, sorry, that is y minus 1 squared plus 4 times x plus 6. So y minus 1 squared, I'm sorry, this is equals 4 times x. Okay. So the value of x here is negative 6, so that is 4 times negative 6 plus 6, that is equal to 4. Negative 6 plus 6, that is 0. That is still 0. So you have here, let us just copy this, y minus 1 squared. So the square root of y minus 1 squared, square root is 0. That is now y minus 1 equals 0. So you transpose 1, that is y equals the value of y. So negative 6 is going to be paired by 1. So we have these three equations. It's really a long equation, right? Let us check. We still have to check this. Let us check first negative 2 and 5. Let us try to make this quick. Let us use the, what should we use? The first or second? Let us use the second, the first one. So you have x plus 2 squared plus y minus 1 squared equals 16. We're going to answer first. Try to check. This is in the checking part. We're trying to check it. So x is, let us label it, x is negative 2 plus 2. Y is 5 minus 1 squared is equal to 16. Negative 2 plus 2, that is 0, right? Negative 5 minus 1, that is 4 squared, 16. That is 0, right? So you have 4 squared, that is 16, equals 16. That is a solution. Let us check this. Let me use the red color. That is a check. How about the second one? Let me the second one. We have negative 2 comma 3. Let me check. So that is x plus 2 squared plus y minus 1 squared is equal to 16. We use the first equation in this case. That is 16. So the x is negative 2 plus 2 squared plus 3 minus 1 squared, that is 16. So that is negative 2 plus 2, that is 4. Hold on, that is 0 squared. 3 minus 1, that is 2 squared, is equal to 16. Cancel, that is 2 times 2. 4 is equal to 16. This is not a solution. Yes, it does happen. Sometimes it could be a solution or not a solution. So we have to choose this. The negative 2 comma 3 is not a solution. And the last one, we have negative 6 comma 1. Let us see if this is a solution. We have x plus 2 squared plus y minus 1 squared. Let me copy the equation first. Okay, so you have x is negative 6 plus 2 squared plus 1 minus y 1 squared is equal to 16. 1 minus 1, that is 0. So 6 plus negative 6 plus 2, that is negative 4 squared equals 16. Still, that is an equation. So we have two solutions, the first and the second. there are two solutions. That's it for the second example. Let us have the last example. Let us see if you are already master with the substitution method. I hope you are having fun, even though it's a long process. So again, first step is to choose which one is the sub. The sub is this, but it could be this too, no worries. Let us label this the sub, this is the primary. So again, vice versa, there's no need to worry. So again, first step, find for the value of y or any variable so that we can substitute it in here. Okay, so let us use 3x as the sub, so that becomes 3x plus 4y is equal to 0. We transpose it to the other side, that becomes 4y is equal to negative 3x, and just to have remain y, divided by 4, cancel. Y is now negative 3x over 4. And we are ready to substitute this thing in here. So that becomes x squared plus negative 3x 4. Don't forget there's a square. Close it in. Squared is equal to 25. That becomes x squared plus negative 3 times 3. That becomes 9 positive x squared. That is x squared over 16. 4 times 4, 16. 25. So our goal is to find the value of x. To do that, let us multiply it by 16 on both sides to eliminate this. So we multiplied it here, but 16 times x squared, that is 16x squared, right? 16 times 9, that is probably 144. 144 divided by 16 still, that is going to be 9. Yeah, 9x squared. Let's cancel this out. 25 times 16, that is 400. So 16x squared plus 9x squared, that is 25. X squared is equal to 400. 25x squared divided by 25 divided by 25, cancel. X squared is equal to 400 divided by 25, that is 60. We're almost there. Square root of x squared, square root of 16, that is x is equal to positive 4 and negative 4. Do not forget, the product of square root, it should be positive and negative 4. We have two values of x's. Let me label it here so that we will stay guided. Solutions are 4 comma blank and negative 4 comma blank. Okay, so we're going to solve for the y. How to solve for the y? Let us use x is equal to, hold on, let me erase this. Is x is equal to 4, and the other side is, let's make this fit, x is equal to negative 4. Let us use which equation? Just this, 3x plus 4y is equal to 0. Other one, same, just to make it uniform. So our x is 4, 3 times 4 is equal to 4, no, plus 4y is equal to 0. 3 times 4, 12, plus 4y is equal to 0. Okay, we transpose this. 4y is equal to negative 12 divided by 4, to cancel it out. Y is equal to negative 3. So negative 4 is paired with y equals negative 3. How about the last one? 3x plus 4 equals 0. So x is negative 4. So sorry, do that one. 3 times negative 4, that is negative 12. Plus 4y is equal to 0. Transpose, that is 4y is equal to 12. 4 cancel 4, y is equal to 3, positive 3 this time. Okay, just to check it, let us check 4 and 3, 4 and negative 3. So let us use the same 3x plus 4y is equal to 0. 3 times the x is 4. 3 times 4 plus 4 times what? Negative 3 equals 0. 3 times 4, that is 12. 4 times negative 3, negative 12 equals 0. So 12 minus 12, that is 0 equals 0. Check. This is a solution. This is a solution. And the other one, the last one, you have 3x plus 4y equals 0. The x is negative 4 plus 4, the y is 3. 3 times negative 4, negative 12, plus 4 times 3, that is 12, is equals to 0. Still a solution. Check. Check. That's it for the substitution method. Let us check if the 3 examples are correct. Let us see and try to go back to example number 1, and let us use the distance calculator this time to prove if they are really equal. These are really the solutions. The negative 3 and negative 3 comma 1 and 1 comma 3. So we have proven that these two are solutions in the example number 1. So to further approve this claim, let us use this distance calculator and see if they really intersect each other. Probably it is a circle. The second one is a linear y minus x. Just input the original equations, the two sets. Okay, so they intersect in 1 comma 3. We got it right. This is check. And you have at what's this? Negative 3 comma 1. You got it right. Okay. So how about with the example number 2? In the example number 2 we use, is this example? The example number 2 is this. The example number 2, we have negative 2 comma 5 and negative 6 comma 1. We disapprove negative 2 and 3. So let us type it in. So you have, let me try to make this quick. You have x plus 2 squared. This could be a circle, right? Plus y minus 1 squared equals 16. Is this a circle or what? I forgot to add the squared in here. This is a square. The second one is y minus 1 squared. I guess this is a parabola because it has only 1 squared equals 4x plus 6. Okay, so they meet at 3 points. I don't know where we got it wrong, but negative 2, is this negative 2 comma 5? Yes, we got it right. This is negative 2 comma 3. So this is still correct, I guess. Maybe we have mistaken something. And the last one is negative 6 comma 1. So we got the 3 correct. 1, 2, and 3. That's it. How about the last example? You have, let me type it in. You have x squared plus y squared 25. We get double squared because 25 equals 3. That is 3x plus 4y equals 0. Oh, they meet at certain points. Negative 4 comma 3, is this correct? Negative 4 comma 3, this is correct. And the other one is 4 comma 3. Wow. That's it for the substitution method. I hope you are not yet tired. Let us continue with the elimination method. Okay, let us solve the systems of nonlinear equations through elimination method. So in the elimination method, we are just going to use the simple addition, and so we all know that in an elimination method we use this if we have the same terms. Example, you have x plus 3 squared here and x plus 3 squared also on the other equation. So in this case we cannot eliminate them, okay, because it has 2. But there is a certain property that if you're going to multiply it by -2, still that is valid. So in this case we are going to look at, again, the first step is look at the same variables on both equations if they have something in common. But we cannot do that because we have 2, so very simple. You're just going to multiply multiply -2 on both sides to make it equal. So that becomes, let me do it here, that becomes x plus 3 squared. Let me copy it first before doing so. 32 minus 16y, and again we multiply, use another color, -2 on both sides. That becomes -2 times x is -2x. No, we cannot do it first yet, so let us just wait for that. Let us just make this that way for now, because our goal is to eliminate. So that is 32 minus, I'm sorry, -2 times 32, that is 64. -2 times -16, that is positive 32. Why, this is 64, I'm sorry. Okay, so now we have transformed this into this. So let us try to pair it again. Okay, these two. So again, this one becomes this because we multiplied -2 in the goal that we can eliminate that. So let me copy it in. -2x plus 3 squared equals 64 plus 32y. And let us copy the second one. 2x plus 3 squared is equal to, and now you can see that it makes sense now. Okay, plus y minus 1 squared is equal to 1. Okay, you can now see the similarity of these, right? So we can cancel that out, but before canceling that out, let us try to align the same terms. So we know -2. Let us continue with the next step. -2x plus 3 squared, and these are the same, a little bit the same, so we align this. So how about y minus 1 squared? Does it have the same thing here? Does not have, so let us copy and let us just align 64. So you have, let us arrange 32y, of course y should be put first, and 64. Okay, 64 is the same with 1, so 64, that is still plus 1. Okay, so let us now eliminate, just cancellation method. So cancel, no, because you're going to add -2 plus 2, that's cancel, that is now 0, leaving us with y minus 1 squared is equal to 32y plus 60. This could be, let me check, hold on, -2 plus 32, hold on, -2 times 32, that is -64, I'm sorry, okay. Okay, so this must be 64, -64. -64 plus 1, that is -60. It's in here. Let me erase this. -63. Okay, so our main goal again is to find the value of x, but in this case we can see we only have y, but that's okay. We are going to find the value of y first. So let me have this label here so that we are kept on track. We're going to find the value of y first, okay, and then we can substitute the x later on. So to find out the y, we are going to combine these things first. So we have this y minus 1 squared. Let us make this a trinomial. That becomes y times y, 1 squared, negative 1 plus negative 1, negative 2y, negative 1 times 1, negative 1 rather, that is positive 1, equals 32y minus 63. How about we transpose all of this to the other side just to combine? That is now y squared minus 2y, this becomes negative 32y, plus 1, this becomes positive 63, equals 0. Combine like terms, that is now negative 34y, did I get it right, plus 64 equals 0. What are the factors of 64 such that it becomes negative 34? That is 32 times 2. But it has to be negative, right? Negative 32 times negative 2, that is positive 64. Negative 32 plus negative 2, negative 34y. So the factors are y minus 32 and y minus 2. And we know we need to add 0. We need to add 0 to find the value of y. We transpose, that is now positive 32. Positive 2. We have the values of y this time. It's really a long process. My pen is running out of ink. Okay, 32 and y. 32 and 2 rather. So we're going to find the value of x. Let us find the value of x. Let us use y is equal to 32 and the other one is y is equal to 2. Both are positive. Let me use another ink because the other one is running out. So you have, let us use either. So in this case we are going to use the first one or the second one. Let us use the first one, a little bit shorter. X plus 3 squared equals 32 minus 16y. We're going to substitute y in here, so that becomes x plus 3 squared is equal to 32 minus 16 times 32. Yes, it is. Let us copy just. Negative 16 times 32. Okay. Negative 16 times 32. I guess that is like a 400. Okay, that is 32 minus 512. So you have x plus 3 squared, 32 minus 512, that is 480. Okay, and then we square it off. We can, yes we can. X plus 3 equals square root of 480. That must be, let me use a calculator. It's 21 to be exact. So x is equal, transpose this, that becomes 21.91 minus 3, that is 18.91. So you have this value of x, 18.91, paired with 32. That's it. How about for y? That is x plus 3 squared is equal to, did I continue this? Okay. X plus 3 squared equals 32 minus 16 times 2, 32. So you have negative 16 times 2, that is negative 32, that is 0. I bring this down, x plus 3 squared, square this off, x plus 3 equals 0, transpose negative 3, that is negative 3. So we have these values in here. So to check this, we can simply substitute, but it would be a long process, so let us use a Dismus calculator to check. So using the Dismus calculator, let us check. You have x plus 3, I already encoded in here. X plus 3 squared is equal to 32 minus, let me check, 2 blah blah blah. Okay, so as you can see, it is a parabola and an ellipse, so they intersect only at negative 3 comma. So one of our solutions is correct and the other one is not a solution. So maybe if we substitute this is not a solution. Let us have one more example of elimination method. Let us start the example number 2. The example number 2, again, the first step in elimination method is, this is elimination method. Example number 2 of elimination method is, first step, look at the same terms. As you can see, most of the time we try to look at the x. As you can see, they're a little bit the same, 2y squared and 2y squared, you can eliminate that one. But how about the x squared minus 2x squared? So again, the first step is to try to find ways to eliminate. So again, this could be added with what? This could be added by 2. But in this case, we can try to eliminate it directly. Okay, let us try to align first. We have x squared plus 2y squared plus 2, this is plus, yeah, it is a plus 2x, sorry, plus 2x is equal to 3. Let us try to align 2x squared, this is aligned, right? 3x squared, 2y squared, yeah, this is minus, I'm sorry, minus 2y squared plus 16. It's good because they are aligned already. So you can simply eliminate by adding them. Of course, we see 2y squared can be eliminated because they have the same this and the opposite sign. So negative 2x squared and x, leaving you with negative x squared, we know that, plus, they are both positive, though, that is 18x, 13 plus 4, 3 plus 14, that is 17. And things are very easy now because we can create a trinomial. Negative x squared plus 18x, 17 becomes negative 17 equals 0. and we try to see the factors of 17 that can become 80. Very simple. That is negative 17 and negative 1, I guess. Negative 17 times negative 1, that is negative 17. Negative 17 plus negative 1, that could be positive or negative. Hold on. That is negative 16 or negative 17. Okay, so it's 18. It's positive 18 times. Did I get it right? Okay. So, I'm sorry. So, you are going to first multiply it by negative 1 so that it can be eliminated. So, negative 1. Negative 1 times negative 1, that is positive x squared. Negative times 18. Negative 18x. Before we can do so, no? So, that becomes positive 17 equals 0. And that is not a time that we can use positive 17. That becomes negative 17 times negative 1. Negative 17 times negative 1, that is positive 17. Negative 17 plus negative 1, that is negative 18x. That is now correct. Okay. So the factors of these are x minus 17 and x minus 1. And we add 0, so we can find the x, that is now transpose directly positive 17 and positive 1. So the values of our x's are 17 and 1. And we go directly to finding the value of y by using the first equation. Let me use this line. That becomes x squared plus y squared, 2y squared plus 2x is equal to 3. X is 17 squared plus 2, y is 17 squared plus 2, is it? No. This is 2y squared. I'm getting drowsy now. That is, I'm sorry, 2x, that is 17 equals 3. Okay, so you have 17 times 7, that is probably 189. Yeah, that's 189. Plus 2y squared plus 2 times 17, that is 34, is equal to 3. And we simply transpose these to other side. Yes, we can. That is 2y squared is equal to 3 minus 189 minus 34. That is now, how much is it? Let me use a calculator. So it is negative 220. That is 2y squared. So we continue by dividing it by 2. Y squared is equal to 110, negative 110. Square root of y squared. Square root of negative 110 that is, but this is negative, we cannot Let us just see. But square root of negative, you cannot have that one unless that is positive. If that is positive, that is positive negative 1049. Let us just see this. But this could be not a solution. X. We cannot square a negative. And yeah, so 17 is an X now. How about the 1? Let us try the 1. Let me copy x squared plus 12. That is 2y. We copy this just here. Original. Squared plus 2x is equal to 3. So x squared is, we use 1. 2y squared plus 2 times 1. This is going to be easy. 1 squared is 1. 2y squared plus 3 equals 3. Transpose 3 to the other side. That becomes 2y squared is equal to 3 minus 1 minus 3. Oh, that is going to be 2y squared is equal to 3 minus 1. Did I get it right? Yeah, it's 1. It's 3 in here. I don't know. What did I 3? It's 2. I'm so sorry. I'm really not on my mind now. You have 3 minus 1. It's really a long video now. You have 3. Okay, that's 0. That is y squared is equal to square root 0. Square root of 0, that is y is equal to positive or negative 0 or 0. So that is 1 and 0. So this is our solution. And we can check that one. Let us try to check. Let us use the first equation again to make it fast. Is equal to 3. Did I get right? Okay. So x is, label it 1 squared plus 2 times 0 squared plus 2 times the 3. Cancel out. 1 times 1, 1. 2 times 1, 2 is equal to 3. 1 plus 2, 3. 3. Check. This is a solution. This time we are going to check if these equations x squared plus 2y squared plus 2x is equal to 3 and so on are really having the solution of 1 comma 0. So I already encoded it here, x squared plus 2y squared in our distance calculator, and it turns out that the solution that we have is correct, 1 comma 0. Okay, that's it for the elimination method. Okay, there is still this one, solving systems of nonlinear equations by graphing. This is the last method in graphing, but I already know that you are already good in graphing. We already discussed the graphing of the conic sections and also with the linear equations. You can study on it and search a little bit if you are a little bit not that master on it. Okay, so this example number 1, probably this is a circle, right? You have the center 3 comma 1 and the radius is 2. You know how to graph it. And the other one is another circle. So we can graph this and find the solution. In which area do they intersect? How about the second one? The second one only has squared, 1 square, the only x. So it is a parabola. The pair of the parabola is y. So y, that is, and then it's negative, so therefore it is going downward. The other one is plus, that is an ellipse. The third one is an ellipse, and the other pair of the number 3 is hyperbola because it's minus. Number 4, that is a circle, and the other one is an ellipse. Okay, so that's it for the solving systems of nonlinear equations by graphing. So now your task is to answer and solve it on your own. This is now your turn to answer. Y plus 1 is equal to x squared, and so on. These are pairs. Kindly take a screenshot, or I'll post it on our LMS. How about the substitution method? The elimination method. Kindly answer these two. Practice solving. And the third one is the graphing method. You graph these two. Okay. So that's it for our lesson today about the systems of nonlinear equations. It was a long discussion. Let us just accustom ourselves with those computations in a even more complex calculus. Thank you so much, and hoping to seeing you in person next week. Thank you, and kindly answer the activities in the arrow links. Goodbye.